Welcome back, students. This is the session 7 from the chapter of work, power and energy. And today I have taken a very small topic, and the topic is notion of potential energy, or you can say notion means the concept of potential energy. So here I have written two bullet points in order to describe the definition of potential energy or the concept of potential energy. So in the first point is the concept of potential energy is applicable to a class of forces where work done against the force is stored in the form of energy. Okay, and when that external constraints, or you can say when the external forces are removed, then it manifests itself in the form of kinetic energy. That is, when we remove the constraint means the forces, then this stored potential energy gets converted into the kinetic energy. Second thing is that the potential energy is defined mathematically as this, that is fx dx. Xi is the initial position of the body, xf is the final position of the body, and is equal to this minus this dv, means we are integrating dv from vi to vf, where vi is the potential energy, that this is the initial potential energy of the body, and vf is the final potential energy of the body. So finally what we are getting is this will be equal to vi minus vf. So we can say that the change in the potential energy, this is the change, you can say it can be written as delta v. So the change in the potential energy for a conservative force is equal to the negative of the work done, and it can be expressed as that delta v is equal to, okay, we can also write this mathematical expression as delta v is equal to minus fx delta x, where delta x is the displacement of the body, fx is the this applied external force, and this is the change in the potential energy, and this is the work done. So now we know that from the work energy theorem, we know that change in the kinetic energy, let us say delta k, this is the change in the kinetic energy, this is equal to the work done on the body by the net force acting on it. So from the work energy theorem, delta k is equal to fx delta x, that is the change in the kinetic energy is equal to the net work done on the body, and so this fx delta x is the net work done, and this is the change in the kinetic energy. So if I take down, this is the, let us say this is equation 2 and this is the equation number 1. So if I add both these two equations, adding 1 and 2, we get delta v plus delta k, this will be equal to 0, because here delta v is equal to minus fx delta x. So if I add this both this delta k and this, if I add both these two equations, I will get this delta v plus delta k is equal to 0, or it can be written as delta v plus k is equal to 0. Now, or we can say that it implies that K plus V is constant. That is, if a body is subjected to a conservative force, then the sum of the kinetic energy and the potential energy will always remain constant. Now, here I have used the word conservative force. Now, the meaning of the conservative force is that it is that force in which the work done is dependent only on the initial and the final position of the object. So, if a body is subjected to a conservative force, then in that case, the sum of the kinetic energy and the potential energy is constant. That is, the sum of the kinetic energy and the this potential energy in the initial position is equal to the sum of the kinetic energy and the potential energy in the final position of the body. That is, we can say that is the kinetic initial energy, that is the initial kinetic energy plus the initial potential energy will be equal to the final kinetic energy plus the final potential energy. So now this equation, this is also called the law of, means basically this is the total mechanical energy of the system. The sum of kinetic energy and the potential energy of a body is the sum of the total mechanical energy of that particular system or object. So this is an important formula here, that is K plus V is constant. This is an important formula, that is delta V is equal to minus Fx delta x, and this one is also important, that is the change in the kinetic energy is equal to the net work done on the body. So this one, that is the equation number 2, equation number 1, and let us say this is the third equation. These are the some of the important formulas which we have to always remember. So thank you very much for joining this session, and in the next session I will be discussing about the potential energy of a spring. So till then, have a nice day. Bye.